Hey, it's John here, and we are doing LeetCode problem 141. We are determining whether there is a cycle in a linked list. Here's a linked list that has a cycle. The final element points back to the second element. Okay, in our solution here, we've created the exact same linked list here. We have a list node has a value and a next pointer. We've created the nodes, set up the pointers to each other, and then in the final pointer, it points back to the second node. All right, let's get started. And our solution has cycle. We have a linked list passed in. The first thing to do is make sure we don't have some degenerate case. So if head is none, return false. We don't have a cycle in an empty linked list. Okay, let's do the naive solution first. Basically, we're just going to keep track of every node we've ever seen and test whether, as we traverse the list, whether we've seen it before or not. So we can just say previous equals, we can make a hash set. Okay, so now we're going to traverse the list while head dot next is not none. And then we will check to see if it's already been seen before. So if previous is if head dot next is in the previous, then we've seen it before. So we can return true, there has been a cycle. Otherwise, we need to add head dot next to our previous. So previous dot add head dot next, or and we are going to move along. So head is equal to head dot next. Okay, if we make it all the way through, we can return false. All right, let's try that out. It detected our cycle. That's good. Let's comment out this cycle. Make sure that it returns false. And it did. Great. We have a naive solution. Let's get rid of that. And we're going to now do a solution that does not have an ON extra bit of memory. So we're going to get rid of our memory of every visited node so that we don't waste that memory. Okay, so we're going to do the fast slow pointer method. So we're going to have one pointer that goes through the linked list twice as fast and one that goes through at a single node pace. And if there's a cycle, then the fast node is eventually going to cycle back around and then catch up to the first node. So we will have a fast pointer which is equal to head dot next, and then we're going to take the second, so head dot next and just head dot next to start with, and a slow pointer at the head. And we need to check for degenerate case where either one of these conditions is none. So if head is none or head dot next is none, then we can return false. There's no loop there. Okay. And now we're going to traverse again. So while fast.next.next is not none. Then we will compare the slow and fast pointers. So if slow is equal to fast, then the fast has come back around and overlapped the slow pointer. So now we know we have a loop. So we can return true. Otherwise, we just increment our pointers. So slow is equal to slow dot next, and fast is equal to fast dot next dot next. Okay, let's try that. Oh, and if we make it all the way through, then we do not have a loop. So let's try again. Okay, that detected the loop. Let's get rid of the loop and try it out. Oops, I commented out the wrong thing. We need to comment out the loop. What happened? None type has no attribute next. There's one too many nexts here. Okay. All right, that worked again. I'll just verify again that it still detects it. All right, there's our solution. Thanks for watching.